Hi, my name is Christian.
And my name is Justin.
I do a little bit of product design and a little bit of product management. Justin and I have worked on a startup before, and we really enjoyed working together. Our other co-founder, so on, couldn't be here for this presentation. He had to go to work, but all of us have been up for about 24 hours. So we're really excited to show you this product. Before we do that, we'll tell you a little bit more about it. So we started with the question of what if AI could show us the future of our terrestrial ecosystems, which is Sustainable Development Goal number 15 for the UN. So promoting the protection and restoration of our terrestrial ecosystems. So about 10 million hectares of forest are destroyed every year. It's a pretty big problem, and a lot of researchers can't really get out to the public the rate at which this change is happening. So we're using stable diffusion models to show the public and to show researchers what our terrestrial ecosystems and forests could actually look like 30 up to even 120 years into the future. So this is an entirely new way of visualizing GIS or terrestrial data that couldn't be done before. So Justin can tell you a little bit more about the process and like how we're doing that.
So over here, you have a very simple interface. You have a search bar for the country, and you have a drop down for the number of years. So over here, I can select that I want to see a country 60 years out. And over here, I can type in the name of a country, and you can see that it auto completes. It suggests right below the search bar, and I just click the country, and then it starts to generate. But it takes a few seconds, so we already have a few results generated over
Yep.
here and
And
over here.
so all of these images are from the Stable Diffusion model. So they're completely unique. And so what we've been able to do is optimize the prompts. So we'll give it a prompt like, country forest over, 30 years with 30% less foliage, right? So what would that actually look like? And these images are generated. And so this allows us to visualize this GIS and terrestrial data in entirely new ways. Like we've never seen like what it could look like what could our planet look like far into the future. And as far as how we collaborated, about 40 seconds left. As far as about how we collaborated, I did a little bit of data processing, mostly product management and ideation, and just ideating the idea and writing some copy.
And I focused on the front end, and Sarwan focused on the back end. The three of us collaborated, split up, divided and conquered, and were able to work together to complete the project.
Yep, we created some APIs, doing services, used Docker, plenty of technologies you'll hear about in the write-up. But yeah, I really appreciate this. We're very excited about this because we think it's an entirely new way to be presenting terrestrial data. And it can really yield some great insight for the public and specifically for researchers to just see like, what their data could actually look like. So in the future, maybe you could feed this some raw data, a little bit more accuracy, train it a little bit, and the stable diffusion model could really show you quite accurately like what that place could look like in time. So thank you so much.